Hello everyone. Today we are going to learn about one of the most important engineering material, that is cast iron and its classification. Cast iron has been used for centuries in various applications, ranging from household items to heavy engineering component. It is also known for its high compressive strength, excellent castability, wear resistance and low cost. Before moving to the classification, let us first understand what is cast iron. Cast iron is an alloy of cast iron, that is iron and carbon, where the carbon is always greater than 2% by the weight. Along with carbon, it contains silicon, manganese, phosphorus, sulfur in varying amount. Because of higher content compared to steel, cast iron exhibit unique mechanical and physical properties. So we will start with the slides. Cast iron is a ferrous alloy, so greater than 2% of carbon. It also contains alloy element, silicon, sulfur, manganese, phosphorus. Cast iron is the least expensive as compared to all metals because of plenty of resources available. Molten cast iron can be easily cast, easily complex shapes, and easily machined. Compositions of the cast iron: carbon percentage is up to 4%, silicon 1 to 3%, manganese 0.5 to 1%, sulfur and phosphorus up to 1%. Cast iron features: it mostly, because of its cheap, it is widely used, or you can say that it is generalized used because it is easily available. It can easily castable in any complex shape. That is also a one important factor to use in the common world. And it is also easy to machine. It also has good mechanical rigidity. What do you mean by rigidity? So rigidity is what? When we apply some kind of a force on a body, it is not going to deform. Or you can say that, or we can say that it is not going to change the shape and size of the parts. It also having strength in compression. When we apply some kind of a compression on it, on the parts, it gives a good strength on it. Example: spherical graphite iron are strong malleable cast iron. So here is the example of, it is the walls, various kind of walls which is made of cast iron, and this is cylinder bores, or you can say that engine, which is used in a various vehicles. Effect of composition element on cast iron. So there are, we have already discussed that carbon, silicon, manganese, phosphorus, it can be add on the iron so that it can enhance the mechanical properties of the system. So first we can consider carbon, that is 3 to 4%. It present in the form of flakes of graphite or cementite, brittle iron carbide. So what is the important properties of the cast iron? It is also a brittle material. We can also have a one example. We can get uh, that is a KitKat. If we apply a force, it can easily break. So it is also one of the examples if you want to consider. Now, when the cast iron having cementite structure, result poor mechanical properties. So application point of view, it required to have carbon in the form of flax or graphite. Carbon. If you see here, there are two different diagrams. If you see the broken area on the above one, it looks like white. So why? Because if in iron having more cementite, it looks silvery white in broken area. That is cementite is a silvery white component. We call it as white cast iron. In the second figure, if we see that the presence of flecks of graphite, the broken area looks like a gray cast iron. So here we can say that if we enhance more cementite, we will see that white cast iron. If we presence of graphite, it becomes a gray cast iron. Silicon. This will some extent govern the form in which carbon is present in cast iron. Silicon causes cementite, which is unstable. Because of it unstable, it decomposes and thus releasing free graphites. Therefore, high silicon iron tends to be a gray iron, while a low silicon iron tends to be a white iron. Sulfur tends to stabilize cementite because it is stabilized, thus help to produce white iron. It gives brittleness property to iron, so we have a keep this percentage as low. The next one is manganese. It gives toughness and strength to iron. It also controls the harmful effect of sulfur in metals. So these are the various to easily melt. It also gives the brittleness like sulfur. For that, we have to minimize the percentage level. Various factor which is affecting the cast iron. First is cooling rate, heat treatment, presence of elements. So first, we can go with the cooling rate. We have already discussed the cooling rate importance in heat treatment process. So we will discuss this next video. So slow cooling result, gray cast iron, and the fast cooling result, white cast iron. Heat treatment. If we prolonged heating 700 degrees centigrade of white cast iron causes graphitization to occur. The cementite decompose into ferrite and graphite during heating up to 700 degrees centigrade. These decomposed ferrite and cementite will occupy more space than the original space. The gray cast iron coarse graphite relatively weak, and the fine graphite tough and strong. White iron, that is cementite, weak and brittle. The type of cast iron, there are different kind of cast irons. Alloy cast iron is used for special purpose. Gray cast iron is for general purpose. White cast iron for heat and wear resistance. Malleable cast iron for heat treated for ductility. Spherical graphite cast iron some ductility. Gray cast iron. Gray cast iron is least expensive, most commonly used. It is alloy of carbon and silicon with iron. In the composition, 2.5 to 4%, manganese 0.4 to 1%, sulfur 0.02 to 1.15%, silicon 1 to 3%, phosphorus 0.15 to 1%. Remaining would be iron. The gray cast iron, if you see the microstructure, there are different kind of flakes which is present in the black shape. Gray cast iron it consists of graphite flakes like potato chips. Graphite flakes are surrounded by alpha ferrite or pearlite matrix. Because of graphite, it shows gray in color. These flakes not having much strength, this lead to crack formation in the edges and brittleness. The shape, size, and the distribution of flakes decide the property of the gray cast iron. Characteristics: it has a good strength. It means we when we apply some kind of forces on any parts which is not going to be deformed. That is strength. Excellent compressive strength. If we compress a part, it gives a good strength on the compressive forces. Good torsional and CI strength, it is also provide. Good corrosion resistance as far as resistance is corrosion is concerned. So that it is also having excellent fluidity. Good wear resistance because it has a hard material. Excellent machinability. It means you can machine easily by using different kind of machines. Good vibration damping capacity. So it also used in the automobile like bikes, cars, etc. Application of gray cast iron. If you see it used in machine tool bodies, engine blocks, engine cylinders, brake drums, crankshaft, pipe and pipe fitting, rolling mills, agriculture applications. Here we see two pictures. What is first is that is the crankshaft, and another one is pipe and pipe fitting T joint. White cast iron. White cast iron derives its name that fact when fracture surface has been easily shown which is in color or white or silvery appearance. White iron combined with cementite. The broken cast iron area looks like silvery white. When the cooling is fast, carbon contents change to cementite, result in white cast iron. Composition: carbon 1.8 to 3%, silicon zero point 0.5 to 1.9%, manganese 0.25 to 8%, phosphorus 0.25 to 2%, 0.2%, sulfur 0.1 to 0.3%, remaining is iron. Here in the microstructure, you will see that white appearance, so that this is white cast iron. The microstructure. Cementite is caused by quick cooling of molten iron. It produces white cast iron. Is very hard and brittle. Rapidly cooling from the casting temperature, the cast iron is termed as chilled iron. Characteristics of white cast iron. As we have already seen in the previous slides, it is very hard and brittle. If the component is very hard, it is a wear resistance, very high resistance to abrasion, high tensile strength, and low compressive strength. It means it has high tensile strength, but the compressive strength is very low. Cannot be machined because it is hard. Application of white cast iron. White cast iron is used as a raw material in production of malleable cast iron, used in rolls, wear blades, brakes, pumps lining, balls, used in outer surface for the car wheels.